So the first part of creating a new class is to say, how am I going to create instances of it? And as I said, that also tends to inherently capture what are the data attributes associated with an instance of a class. But now I need methods. I need ways of manipulating those attributes, those data attributes. And so, first of all, what's a method? It's a procedural attribute. Think of it like a function, but a function or procedure that works only with this class. It's designed for that class. As an aside, as I said earlier, that's nice because it says I can use the same name many times doing similar things for different classes without worrying about the confusion of the name. Now, when I define a method, Python always passes the actual object, the instance, as the first argument. And so the convention is going to be to use self as the name of the first argument of all methods, not just init. As we've also seen, and we're going to see now an example of it, the dot operator is going to be used to access any attribute. Certainly the data attributes, the variable names, but also the method. And we're going to see an example of that in a second. But first, let's look at actually making one of these. So let's go back to my coordinate definition. I already said I might want to compute the distance between two coordinates. So I can add a new method. And here it is. I'm going to define distance. And notice with both of these, and I should have said it earlier, these are now just standard definitions of procedures. They happen to be indented inside this class definition because they belong to the class. So I'm going to define distance. As I said just previously, we need to have the first argument be self because it's going to refer to a particular instance. It says, here's the method I want to do on this instance. In this case, I've also got another parameter because I want to measure the distance between a particular coordinate and some other coordinate. So I'm going to give it a name. I'm going to call it other. Within the body of that method, I just do the standard work I would do. I'm going to compute a couple of things. I'm going to return a value which is just the sum of the squares, the square root rather of the sum of the squares. The only other nuance here is I'm using dot notation to access the data. Other than that dot notation, everything else behaves just like you would expect. What's the dot notation doing? Well, as we already saw when we wanted to get values out, I need to do that to get the values associated with instances, not only for self, but also for this other coordinate. And just as I did in the earlier example, think of other.x as saying, get the value of other. It points to a frame because it's an instance of a coordinate. And in that frame, when I created it, I defined variable bindings for x and y, retrieve those variable bindings. But there's now a nice little method for computing distance. And so I could actually use it. And in fact, let me do it. I'm going to go over to my machine and I'm going to make sure I have that definition in place, and I do. And I've got C, and I've got origin. So let's do the following. I've defined C and origin as before. I can print out what is the distance from C to the origin. And it says it's distance 5, which makes sense. 3 squared plus 4 squared is 25, square root is 5. Notice how I called it. I called it by saying, first of all, what's the object on which I want to call the method? In this case, it was the coordinate C. What's the name of the method? And then what's the parameter I want to use? But again, notice I did not provide anything for self. And this is because in this particular version, C being a frame, I look up the value of distance. It is a method within it. And because I'm using it associated with that particular instance, Python automatically provides C as the first argument to this distance function. I could do it a different way. Again, I could have C as a coordinate, origin as a coordinate, and I could do the following. I could print out the class coordinate dot distance of C and origin. And that might look a little more reasonable to you because now I'm saying what's the distance between C and origin? And if I do that, I also get out 5. What's the difference here? Now I'm giving it the name of a class. What's that? Well, it actually also points to a frame in which all the class definitions are created. So inside of the coordinate frame, I'm looking up the distance method, and that takes 2 arguments, and therefore I apply both parameters, C and origin. If I'm using an instance to get the method, Python automatically uses that instance as the first argument. If I'm using the class to get to the method, you need to provide both arguments because Python doesn't know which is the instance that you want to use. Think of it this way. Coordinate is pointing to a frame. inside the scope of that frame, we created methods when we created that class definition. So coordinate.distance basically says get the value of coordinate, it's a frame. The dot says look up the value of distance within it. I get that, that's a procedure definition. And then I apply it to the arguments that are provided. C.distance doesn't have a distance method defined within C, it's just an instance. But because it's an instance of the class, it inherits that distance method from it. And as we said, Python automatically uses C as the first argument. I'm belaboring this point because I guarantee you that you are going to somewhere in the near future make the mistake of either not providing an argument for self or providing one when you don't need to. And so this slide hopefully gives you a way of separating out the two differences. Okay, now that we got them, we might want to look at those coordinates. So I could just print them out. And I could go back to my machine and say, print out C. And it gives me garbage. Well, I shouldn't say garbage. It gives me actually information that says within the main environment, this is an instance of a coordinate object, and here's the actual memory location at which it lies. I guess I could go in and start playing with that memory, but that doesn't make a lot of sense. This is clearly an uninformative representation, and that's because by default, this is what it prints out. I'd like it to have it print out something that's much better at representing what a coordinate looks like, and I can do that by defining another method for my class. This is another special method called the string method, and it's typed as underscore underscore str and then 2 underscores as well. Whenever I ask to print an instance of any kind of data object, Python is going to call the string method that was used or was as part of the definition of the class. And you get to decide what it does. By the way, even with existing object types, there is in essence a string method associated with lists, a string method associated with tuples. So, say we want to have our string method actually produce something with an angle bracket and then the two coordinates separated by a comma and another angle bracket. Well, I could do that, and it's actually pretty easy. Right down here, I'm going to define that special method string. It's going to tell me how things are going to print out. And all I require is that however I want to define it, it must return a string. And so if I go back over to my machine and I'm going to uncomment that string method, now I can evaluate that. And I'm going to define again C to be the coordinate of 3 and 4. If I print C, oh nice, it prints out a much better representation of the coordinate, something that I can recognize. And that's going to make it easier to think about what's inside of that coordinate. Having done that, I can now also think about a few other things I might like to do with classes. I could say, what's the type of this particular object? So I could print, as you can see there, what's the type of C? And it actually gives me back something that makes sense. It says C is an instance of a class, and the class type is coordinate. The dot main just tells me it was defined up in that overall environment to which I interact, that Python environment in which I interact. And in fact, it makes sense because I can say both what is a coordinate, it's a class, and what's the type of a coordinate, it's a type. So I can make instances, I can measure things about them, I can print them out. One of the other things I might want to do is to know what kind of thing is this? Do I have something that's an instance of a coordinate? I could do that by looking at the type and trying to check what's the type of this thing. But you've already seen right here that the type of C is this complicated thing. I really don't want to write, is the type of this object equal to class underscore main dot coordinate? That's messy. So instead, I'm going to use another built-in method associated with any object, which is instance. And I can use that to check if an object is an instance of a coordinate. So I can say, for example, is C an instance of coordinate? And it says, you bet. I could do that with built-in objects, by the way, saying, is this thing an instance of a list? Is this thing an instance of an int? I can often do shortcuts in those cases, but that underlying method of isInstance comes from basically the objects that exist within Python. We also have a few other methods that we saw with other kinds of objects that we can build into our new class definitions. There's a long list of them. I'm going to simply let you go look them up, but basically many of these come provided, but I can override them. And the standard ones are I can define what it means to add two instances together, to subtract them, to test if they're equal, to test if they're less than, to print out the length, and we've already done print here, that's the str. Each one of these methods has a built-in name that I can use to override the underlying version of that. So for example, imagine I want to subtract two coordinates. I could do that by simply defining what sub should look like, and I'm going to do that by going to my computer where I've built one of those in. And what sub should do is simply take the instance itself and another instance, subtract coordinate-wise the x values, and then return a coordinate. And if I run that, again, I'm going to create two versions of it here. I'm going to let C be the coordinate at 3, 4. I'm going to let origin be the coordinate at 0, 0. And if I want to say C minus origin, great, I get out a coordinate. Let's give it a name. And I can print foo, and it gives me back what I would expect, which is just the vector between that point and the origin. Key thing to note here is I can have my method return simple values. I can also have it return new instances of things I created, and that's a really nice thing to have.